Good day to everyone who's watching. In our lesson today, we're going to talk about sets. Defining a set is very simple. It is just a collection of objects or ideas. It can be a collection of senior 1 students in a school. It can be a collection of science teachers in a given school. It can be a collection of given workers in a given company. So these objects or ideas in a set, they are named by either describing them or listing them down. So we can talk about the symbols that are used. First of all, the capital letters. We use capital letters to name the sets. For example, my set A, that is capital A, is equal to that. You can use any set B to be equal to, let me say K, L, M, N, like that. Then if we want to know the number of elements or members in a set, my set A given as A, B, C, and D. So the small n brackets into the name of the set gives me the number of elements or members in that set. If I want to write the empty set, so this is how I write it, or the other one. Now we must talk about the relationship between sets. One is the disjoint sets. Those are two sets which have no members in common or elements in common. For example, my set P and set Q there, you can see that there is nothing, they are totally different. They are totally different. In real life, those disjoint sets, we can have senior 4 students and farmers, a set of farmers in Kawanda, and the senior 4 students also in a certain school. So those two sets are totally disjoint. We also have equal sets. Those equal sets, elements that are in one set, they are also in another. For example, if I'm having my set A and B, I'm having the elements there. Those that are appearing in A, they are also appearing in set B. When we go to the intersection of sets, those are sets that have elements in common. And the intersection of A and B, sets A and B, is denoted as that. Now we talk about the union of sets. Suppose I have set A and B. The union of sets A and B is just a single set consisting of all elements, either in A or B or in both of them. For example, if I'm having this, the set I'm talking about, A union B, is the whatever is in all those two sets or in both of them. Diagrammatically, or the Venn diagram, though we have not yet reached there, this is how it looks like. I'm having my set A and set B. The 7 and the 5 is common there in set A, and also set what? Set B. That is where the intersection is. Then the rest, the 3, the 1, and the 9, they are in the A. And then the 2 and the 11, they are also in the B only. Subset, when we talk about the subset, members of one set are all elements of another set. Given my example here, example A. So my set B is a subset of A. Set B is a subset of A. Diagrammatically, this is it. My set B is inside the set A. So the elements there, the way they are here, I put them in set B, and then the rest that are in A, I put them outside the set B. We can talk about the number of subsets, that is 2 power n. Number of proper subsets, that is 2 power n minus 1, where the n is the number of elements or members in a particular set. For example, if I'm having my set Q given by A, E, U, and M, find the number of subsets. Those number of subsets, they are going to be equal to 2 power n, which is equal to 2 power 4, because the elements here are 4. So 2 power 4 is equivalent to 16 subsets. Then lastly, we can talk about the complement of a set. These are all members that are not in a described set. So suppose I have set A, its complement is denoted as that, or like that, a backup, or. So the Venn diagrams, we have one here. Suppose I'm having two sets, A and B. Then we say that that n into the brackets, the name of the set, we say that means the number. So I'm having my sets A and B, their numbers are there. So the A comprises of whatever element is in there. That is why here I'm saying that my number of A is equal to my number of A intersection B complement plus number of B intersection A. Then the same applies to B. You get whatever comprises there to give you the number of B. That is the number of A intersection B plus the number of A complement intersection B. So the composition of these ones here is what constitutes the A union B. So my A union B is, when you add that, then even that region there. When you try to substitute these two formulas in there, we shall arrive to that formula there. So my number of A union B can be also got by the number of A plus the number of B minus the number of A intersection B. Then there are elements that are not in B and not in A. Those elements, we put them outside those sets. This is it, the number of A complement intersection B complement, or we can call them the number of A union B complement, when the complement is outside the bracket. And the sum of these two regions, this and these ones here, is what we get by the number of the universal set. That this one here, we looked at it as the symbol of the universal set. Now, the A intersection B complement, this region here, sometimes we can call it as A only. So this is number of A only. Even this one here becomes number of B only. So that is our Venn diagram of two sets, and you can use it to get even probabilities. So we shall look at, when we look at probabilities, we shall try to get some of them from the set.